Hello, this is Laura Alford. This video is going to be on weights and centers. So in some previous videos, I've talked about this weights and centers method for calculating kg, and so now we're finally going to get around to doing it in some detail here. So for our stability analysis, we have these four main points. We call the metacenter, the center of gravity, the center of buoyancy, and the keel. These give us these various lengths that we need for our stability analysis, the most important one being GM. That's what we're trying to get to, which is the metacentric height. Right. So for initial transfer stability, we've got GM is equal to Km minus Kg. Not a very difficult calculation, right? Km we get from ship geometry, and Kg we get from ship loading. Right? And if GM is positive, then the ship is stable. If GM is 0, then the ship is neutrally stable. And if GM is negative, then the ship is unstable. Kg we're going to calculate specifically using this weights and centers method. All right, so for the ship loading itself, we've got some general categories of weights, right? There's the light ship weight, which is the hull, machinery, outfitting. It's all the stuff that doesn't leave the ship ever. The cargo, you got fuel, personnel, fresh water, ballast water, etc. For the centers themselves, we have vertical, longitudinal, and transverse centers of gravity for each item, and then you combine all of the above to calculate the kg for the entire ship. All right, so here's an example. Here we have a ship. For the light ship weight, we have some structure, right? Each of them has its own little center of gravity here, marked with a little red dot and a lowercase g. So you've got structure, you've got some machinery, some outfitting, some cargo, fuel. I've got some ballast water in here, some fresh water for drinking. You got some stores, you got some more stores, you got some even more stores, and you got some personnel, right? And now your ship looks like it has some sort of horrible disease. But if you take all those together, and then that gives you the total ship weight, and the total ship weight is going to act through the overall center of gravity, g. Right. Once we calculate g, we can compare that to where the keel line is, to where m is, and from that, put in center of buoyancy, and now we're talking about longitudinal transverse stability, right? So the whole key to this is estimating, or calculating, I should say, kg from your ship loads using the weights and centers. So why do we care where the center of gravity is? Well, the three reasons for each of the three dimensions. So for stability, we care where the vertical center of gravity is, because hopefully g is underneath m, because otherwise your ship is going to be unstable. For the transverse center of gravity, it depends on where it is in relationship to the center line. If it's on the center line, then your ship will be on even keel, and that will be good. If it's off to the side, then your ship will have a list to it. And then finally, for the longitudinal center of gravity, we compare that to where the center of flotation is. If they do not align, then your ship will have some sort of trim to it. Right. So calculating the centers is really not that difficult. There's just a lot of numbers to it, if you will. So the weight of the ship times the length to the overall center of gravity, kg, is equal to the sum of all the individual weights times their length to the center of gravity. And it's the same calculation here, whether they're talking about kg or TCG or LCG. Right, for this here, I'm going to use capital letters are going to refer to the overall ship characteristics, and lowercase letters are for all of the individual things that we're talking about. Here. Then to find the lengths of the CG, so like kg, TCG, and LCG here, it is a weighted average, is all it is. So you take the sum of all the individual weights times their length to the CG, and then you divide it by the total weight of the ship. So here's a quick example. All right, we go back to our equation here. We need to find these three things, all right, to get kg. So we set up, the easiest way to do it is just set up a table. So you have the item, you've got its weight, its center of gravity, or kg, and then the moment of the two of them, all right? So you're given these numbers, right? You've got the light ship, you're told it has this weight and it has this kg, so you multiply them together to get the moment in the last column. You got cargo, fuel, fresh water, crew, however many things that you've got. At the end, you sum these two columns. So now you calculate the total weight of the ship, because it's just the sum of all the individual weights, and then now you've summed all of the moments. Okay. So going back to our example here, or the equation, we've got the sum, kg is equal to the sum of the moments divided by the weights. So we now have these numbers. You plug in these numbers, and then you get the total kg is 9.2 meters. So again, So now you know this, right? kg, so now you can go back to your and complete your stability analysis. That's really all there is to it. It's not difficult, right? I mean, it's just adding things up and dividing them. But it's a lot of bookkeeping. So when you're doing this, you got to make sure that you haven't lost a number somewhere, flip something around. Each of those sections in the little table that I showed was itself a weights and centers calculation, right? So the light ship has a whole bunch of stuff within it. Cargo would be all up and down the ship. And so again, you keep building on this. You do weights and centers, and you get an overall one. And then if you get an overall one, then you can work from there. But this process is the same. Like I said, not difficult, just a lot of numbers. Anyways, hopefully this helps. As always, thank you for watching.